Okay, in this question we're given that a company found that the price demand function for one of its products is given by this formula here, which is a nice linear formula. So the graph of this will be aligned with negative slope. Okay, good. So good to know from the beginning when you're looking at anything is what sort of graph would it give? What kind of function is it? What kind of relationship? So it's a linear relationship. So here first we need to find the revenue function, R. Remember the revenue is just you multiply the quantity by its price. The quantity, Q, by the price of Q. And so this will be Q times, P of Q is given here, 75 minus 0.2Q. And so this will be 75Q minus 0.2Q squared. In fact, I mean, usually we write R in terms of Q, but sometimes you might have it in terms of X. This is given in terms of X, the price, and in this case you'll have the revenue as a function of X will be XPX. If it was given to you this way, so it will be X times 75 minus 0.2X, which is 75X minus 0.2X squared. You see, and then you take, if you want in part B to take derivatives, then you take it with respect to X. But because everything is given in terms of Q, we will do everything in terms of Q. Okay, just to let you know from the beginning, I'll use Q now as my independent variable. So find the instantaneous rate of change of revenue when the production is Q equal 50. So they want you to find instantaneous rate of change, so dq by dr by dq when Q is 50. This is what they're asking. So first we need to say what is the derivative of revenue with respect to Q. It's here. Take the derivative of this. It will be 75 minus 0.2 times 2 is 0.4 Q. That is the derivative. Just like, you know, if you had 75x minus 0.4x squared, that was your revenue. Then the derivative, remember, it will be 75 minus, now the 2 comes down and it hits 0. Actually, it was 0.2. So R of x is 0.2 here. Here is the formula. I copied from here, so by mistake. So minus 2 times 0.2. Now this will be 0.4 x to the 2 minus 1. And 2 minus 1 is 1. Okay, derivative of x squared is 2x. That's what we're saying. So this is the derivative, and now it means that the instantaneous rate of change, or the derivative, when Q is 50, will be 75 minus 0.4 times 50, which is, and now let's use the calculator to do it. Even though it's simple, you can do it in your head. 0.4 times 50, that's 10.4 of 50. So let's see, 0.4 of 50. It's 20, sorry, it's not 10, 20. Yeah, so 75 minus 0.4 times 50 equals 55. So with a positive, so it's an increasing function. So R is increasing near 50 because this is a positive answer and it's 55. That's the derivative at 50. Good. Now find the exact revenue the company gets from selling the 51st item. So the revenue from the 51st item will be the revenue from selling all the 51 items minus the revenue from selling 50 items, the first 50 items. This will give you exactly how much revenue will you get just from the 51st item. So just replace in R. R is here. I'm going to do it. So 75 something minus something. The first one is R of 51. It's 75 times something minus 0.2 times something squared. I like to write the entire formula first. 75 times something minus 0.2 times something squared. And now we fill in the gaps. We'll say 51 in here and 50 in the second formula, which is the same formula, just R. I'm doing R of 51 minus R of 50. You can do it in your calculator. You'll get 54.8. See? 54.8 is the exact revenue from selling the 51st item. But notice, it's very close. They are very close to each other, because this is close to R prime at 50. You know, R prime at 50, the marginal revenue at 50, if you want, a way to compute it will be R of 51 minus R of 50 over 51 minus 50. Because you want the instantaneous rate of change. This is not a real equality, it's an approximation. And because 51 minus 50, this is always 1, that's why you saw the formula as the marginal revenue at 50 is approximately the same as the exact revenue of selling the 51st item, which you get by subtracting the revenue of selling 51 items minus the revenue of selling 50 items. That will give you the revenue from the 51st item only. Okay, good. And it turned out to be 54.8, if you want, in this case, dirhams or dollars, depending on the question. And the one that you got from the derivative was 55, pretty close to each other. But this one here, the 55, you did it without knowing what R of 51 is. So you can assume that you knew up to R of 50 everything about R. And you were predicting what R of 51 could be. And you can get it by knowing the R prime of 50 and R of 50. They will give you information about R of 51. This is just what I did here, if you understood it. Otherwise, you can see that they are very close to each other. It will always be the case, because that's exactly what the derivative helps us doing. In part D, compare your answers in B and C. What do you notice? Well, we notice that dr by dq, this marginal or instantaneous rate of change or marginal revenue at q equal 50 is approximately the same as R of 51 minus R of 50. Because one of them, this was 55, the other one was 54.8. Those numbers are close to each other. And it will be always the same at any point, dr by dq, at any point, if you like, n, this is approximately R of n plus 1 minus R of n for any function. And whether you use q or x, the revenue as a function of x or as a function of q. In this case, because we're using q, I'm doing dr by dq. Yeah, at any point n, so n, let's say, is 15, then you'll put R of 16 minus R of 15. Okay, one more, I'll write it just like this. dr by dq at 17 is approximately R of 18 minus R of 17. Okay, it will always be like this. And is this the end of the question? Yeah. And so I'll stop here.